show you one video that will give you an idea what I'm trying to explain. Is that fine? Hello?
Yes, sir.
Yeah. Are you able to see my screen, sir?
Yes, sir.
The Internet of Things, or IoT,
Now?
is influencing
Yes,
our
sir, yes.
lifestyle and the way we react, the way we behave. From air conditioners that you can control with your smartphone, to smart cars providing the shortest route, or your smartwatch which is tracking your daily activities. IoT is a giant network of connected devices. These devices gather and share data about how they're used and the environment in which they're operating. It's all done using sensors. Sensors are embedded in every physical device. It can be your mobile phone, electrical appliances, vehicles, barcode sensors, traffic lights, and almost everything that you come across in day-to-day life. These sensors continuously emit data about the working state of the devices. But the important question is, how do they share this huge amount of data and how do we put this data to our benefit? IoT provides a common platform for all these devices to dump their data and a common language for all the devices to communicate with each other. Data is emitted from various sensors and sent to IoT platforms securely. IoT platform integrates the collected data from various sources. Further analysis is performed on the data and valuable information is extracted as per requirement. Finally, the result is shared with other devices for better user experience, automation, and improving efficiency. Let us look at a scenario where IoT is doing wonders. In an AC manufacturing industry, both the manufacturing machine and the belt have sensors attached. They continuously send data regarding the machine health and the production specifics to the manufacturer to identify issues beforehand. A barcode is attached to each product before leaving the belt. It contains the product code, manufacturer details, special instructions, etc. The manufacturer uses this data to identify where the product was distributed and track the retailer's inventory. Hence, the manufacturer can make the product running out of stock available. Next, these products are packed and parceled to different retailers. Each retailer has a barcode reader to track the products coming from different manufacturers, manage inventory, check special instructions, and many more. The compressor of air conditioner has an embedded sensor that emits data regarding its health and temperature. This data is analyzed continuously, allowing the customer care to contact you for the repair work in time. This is just one of the million scenarios. We have smart appliances, smart cars, smart homes, smart cities, where IoT is redefining our lifestyle and transforming the way we interact with technologies. The future of IoT industry is huge. Business Insider Intelligence estimates that 24 billion IoT devices will be installed by 2020, and IDC predicts that IoT revenue will reach around 357 billion in 2019, resulting in a lot of job opportunities in the IT industry. Want to become a part of the IoT revolution? Come and master IoT with EduReka.
Were you able to hear the sound properly?
Yes, sir.
Yes, sir, it was very clear.
Okay, so actually this is a promotional video for EduReka too. So that's a tutorial site. It will be helpful also, just sort of giving that information also to you. So latest technologies, every tutorials and all you can find that. So in that video you can see all these. Okay, sorry. All these devices which we use are emitting data. Okay, so you may not realize you are emitting data every day. So by 2020, it is calculated that that's the right year. So this calculation was done before, like 1.7 MB of data will be created by everyone in the world in each and every second. Okay. So that is average. So someone is not using smartphone or smart devices calculating that also. 1.7 MB of data will be generated every second. So when you realize, you can see that. So your mobile phone, the videos you are taking, the pictures you are posting, and the CCTV surveillance cams, 1 year circle when we cover, there will be hundreds of CCTV cameras, right? So all these things are getting, data is getting collected, and we have the mechanism to analyze this data within short span of time. So then bulk of this data and statistical algorithms, that's where machine learning came in picture. Because using this statistical data, we can derive, predict future, that kind of things we can implement in software. So I was mainly dealing with software robotics, so mechanical. So in the previous sessions which I saw, most of you are like interested in mechanical robotics. So we have a link for that too. I was working for connected car, I mean the autonomous car project, but there also we are using this data analytics and software AI part. Okay, so mainly the mechanical part, it was taken by a different team. So I'll be mainly concentrating on software robotics. Okay. So this is basically the types of machine learning. So suppose we have a label data. Label data in the sense we know the features, so which are the statistics and the result what we are going to calculate. Suppose maybe your students' details in your class, how the attendance going on, how many hours of class students are attending, and maybe based on your review, internal marks, all those based on that statistics, how their result is associated. So that we can consider like a label data. Okay, so maybe few years of experience, you can predict one student how his result will come. So like in machine learning, we can make it bigger. Make it bigger means one simple person cannot do the complete dimensions which machine learning is going to calculate in the model. Okay, so somewhere humans will be smarter to predict, but the bulk amount of data where human cannot handle. So that kind of things, machine learning will be a solution. And you can see in Amazon, Flipkart, all those online, you can see that you will be forced to buy something, right? So recommendation engines, that kind of things are coming from supervised learning. So they have label data, statistics, and they will come out of the prediction which product there is a chance to buy. So that they will display to us, and their business goal is like increasing their sales. So that is the main intention of recommendation engines. So apart from that, unsupervised learning, so there will not be any labeled data. So it will be like based on some statistics details, clusters will be formed, that kind of, and we will categorize based on that features some specific categorization. That kind of things in supervised training, unsupervised training. Reinforcement is when considering deep learning. So that is kind of neural networks and all human have created. So it is kind of a human brain analysis implementation, like weightage, using weightage, calculating the propagation and backward, that kind of calculation will be happening inside the machine learning engine. So these are the types of machine learning. And the same thing, so categories what kind of things we can do under each and every section. Okay, sales forecasting, risk assessment, predictive analysis, and all we can do using supervised learning. So unsupervised learning is like sales functions, categorization, performance monitoring, that kind of things. So based on the result of a specific cluster, that kind of things we can do. And semi-supervised learning, so some of the data we can get labeled, so result we can, and a mixture of structured and unstructured data. That comes when semi-supervised learning can be implemented. And reinforcement learning is like completely neural network oriented calculations. Okay, policy creation, linear tasks, network creation, that kind of things you can do. So we'll come to that later in detail. So these are the terminology. So always in any kind of this machine learning, super, unsupervised, or reinforcement learning, this will be the common terminology. The features are like the input, the statistical data which is going to be considered in the machine learning model. So that we call features, and the samples are the values. So for each and every features, what are the that's we call samples. And feature vector, so when we input the data into a machine learning algorithm, so it will be like vectorized form. So that we call feature vector. And training and evaluation set is like, see, when we train the model, when we feed the data into model, we split it into test and training data. So we can analyze how correct is the model predictions. So based on the test set, so it's coming from the same data set, same observation which we are going to use to train the model. So for evaluation purpose, we split it into mainly 70 to 30%, 70 to 30% like that. We will split the data and train the models. Okay, I think you might be familiar if you have done something. So this is the workflow. So table data, this is for a supervised learning. So we'll feed it into a machine learning algorithm. So fitting the data into the model. And once the model is created, then the new incoming data, say suppose similar kind of situation is going to happen. So the present time here we got the data, so we can predict that situation, what is going to happen next. So based on that, real time, we can direct the user based on the intention, based on that model. Okay. So deep learning algorithm, this is kind of calculations happening in a deep learning neural network. So that is similar to brain function. You might have read the theory already. It's like based on weightage. Suppose if you are going to buy a car, a human will be thinking a lot of factors, right? So the money he is having in hand, the features which he need. So he will compare all these things and make a decision like what is the best for me. So that similar kind of calculations will be happening here. So using functions, we can create the model as we want. Okay. So this is almost same, just showing the workflow, training process workflow. It is similar to the other learning models, but the function, the how it functions, that is only the change. Apart from that, we have natural language processing. So we are using Python based NLTK framework, that is for voice recognition, question answering machines, dialogue system, text summarization, report generation, and all. So we can consider this as semi-structured, semi-supervised learning. Okay, so it comes in that category. This is actually a flowchart. So even for an experienced programmer, it will be difficult to find out a right algorithm to use for a specific purpose. Okay, so if you go to this link, I will open that link. Okay, so this is Scikit-learn project homepage. Okay, so this is a Python framework for machine learning. Here, if you go to this link, you can see that when we start with the data set, there are some questions here. So the number of samples we have, labeled data or not, more than 10K samples, weightage, all those things you can consider. So once we arrive in a category, so you can see that there are some algorithms listed. And when you mouse over, so that specific algorithm you can click. So it will be redirected to a page which is giving the complete theory and implementation samples of that specific model. Okay, you can easily try. You can just copy this code and paste. There will be sample inputs, and you can try that algorithm specific implementation. That's why I just thought of opening this link, because in this picture it will not be visible. So this is one very useful when I started with my projects. It was very helpful for me. So this will be a very useful one for you also to identify the right algorithm for your implementation. This is again the list of common algorithms and the purpose of most of those implementations. Okay, I will share the slides, so maybe you can go through this list for a detailed lookup, and the function maybe based on the description also you can find the right match. This is also saying this is what's a wider list of algorithms which is getting used in normal software AI projects. So if you search for this in scikit-learn, you will get the implementation for that specific functions, algorithms. Okay. Then comes cloud computing and how robotics is related to cloud computing. You might have used Amazon Alexa, right? Anybody using Amazon Alexa at home? Rhythm?
Yes, sir. Yes, sir.
Okay, so that device, if you see, you can see that like it's a cheap device. So the basic one we will get for 3,000 rupees. The main device inside that main component inside that device is like a good speaker. Okay, apart from that, there will be a mic and a mobile, low-cost mobile processor will be there. All the things. So whatever you ask to Alexa, you will get a good answer. Okay, so even it can play songs. Apart from that, you can ask any questions. It's kind of a Wikipedia. Okay, if you ask any questions, you will get the scientific answers to comedy answer, anything. And the speech recognition, everything happens. That is not inside that device actually. So the calculation is happening somewhere around the world. We cannot say that. Okay, so maybe theoretically it will be the nearest geographic location, but it could be anywhere in a distant server. So if it is not connected to internet, that device cannot do anything. Okay, so it's the major functioning of that device is happening in the cloud. In the cloud means the machine stored connected to internet somewhere around the world using that infra. The similar thing, so Amazon Alexa is a robot actually. It's a AI robot. So the similar way, any robot we can design. So the good thing is device and location independence. Device, we don't need to implement the complete processing infrastructure inside the robot. The brain can be outside the robot, and only the mechanical parts we can implement in the body. Okay, so that is like that is where cloud computing is getting important. Significant workload shifting from local computers. Okay, so if you are implementing a local computer in every robot, that infra itself may be a big problem for that purpose. Okay, so maybe your weight of your robot will increase, and that kind of problems will come. So if you can make it in the cloud, the software part in the cloud, there are so many other benefits also. Say, suppose you need to give a software update for your robot. So in that case, you can update it remotely, and you don't need to physically reach that device. So that kind of convenience is there. Sharing resources and cost across the. Okay, so the cloud infrastructure can be used for multiple devices. So based on the workload, we can make it available for multiple devices. High reliability and efficiency. So when we implement this in local infrastructure, everything, so the data backups, data protection, maybe the mechanical defects, everything we need to take it. But in the cloud infrastructure, the storage and all those things will be by default, 3 replicas will be there for our data. So its chances are rare to lose that data. Like 100% sure we can, the data is safe. Also, supporting and improving software, that is easy. So we can update anytime remotely the software system. So nowadays, cloud computing is like very playing a big part in robotics. So these are the survey of tools which we are using. You can see TensorFlow. TensorFlow is a widely used machine learning platform. So that is implemented by Google. Okay. PyTorch is the similar implementation by Facebook. But the problem is Google is really aggressive in AI area. So they are providing free, Jupyter Notebook, right? Similar implementation is there from Google side also. It's called Google Colab. It will be like really good to use. That's a free of cost infrastructure which is cloud based. Anyone can start using that. The benefits are similar. So if you are not having a good configuration machine, that's not a limitation to try any of these machine learning algorithms. Because machine learning algorithms are resource hungry. You need a graph GPU processing unit for some specific calculation, high-powered CPU. So practically, it is not possible to build a system at home to process these kind of data. So Google is providing that infra for free. We can use Google GPU for machines using Colab. So the process will be happening somewhere in the cloud, in Google infrastructure. Anybody using Google Colab? Have you anyone used Google Colab for any sample time? Okay. PyTorch is by Facebook. As far as the technology availability, Google is very advanced. So they are providing open source, most of the implementation open source, and the reach is very high, and the infra based on this Colab and all that is also like we can get it for free. So 96% of the market share, like in deep learning, is like TensorFlow, not 90%. I think it's really, but still, it's like relatively very high usage. TensorFlow is like the most famous one, and Keras is actually a wrapper for TensorFlow PyTorch. So most of the deep learning algorithms and all we can simply implement using Keras in wrapper. Okay, it will be very straightforward. TensorFlow alone, if you implement something, it will be really complicated. To understand the coding part, it will be like relatively tough when we use only TensorFlow. That's why Keras wrapper is getting used. The tools we use mainly based on Python. Our implementation is like mainly based on Python. So there are different languages. Okay, so MapR, R language, a lot of things are there. Okay, so mainly we use Python-based frameworks. That is because data scientists mostly they will not be having much idea about programming. Okay, so they'll be using Python. That is relatively easy to learn. So they'll be using Python to implement their logic, and they'll send that code. So converting it into a different language will be difficult. And also now the computing infrastructure, the fastness of the computing is not a matter now because we have such powerful systems. So Python, comparatively, the Python execution time is little higher, but still because of the convenience and even once we submit the jobs into these frameworks, it is in another execution pipeline. Okay, so that how we implement that logic, that is not a question. It will not be a matter for the speed of that engine. So Apache Spark. So this is for data analytics. So that we discussed before big data analytics. So right now, initially it was Hadoop platform for distributed for the first one. So then later in-memory processing was introduced in Apache Spark. So most of the 90% of the data analytics is done using Apache Spark. So that is the fastest distributed framework available right now. Then scikit-learn. Scikit-learn is a open source Python library. That's what the homepage I showed you already. There you can find almost every algorithm implementation and the usage tutorials, everything you can go and refer from that site. Okay, and the samples also will be there in that tutorials, and also in the documentation you can find answers for anything. TensorFlow, we discussed already, then Keras, PyTorch. Now, Amazon and Azure cloud providers, they are providing some machine learning frameworks. Okay, Amazon machine learning framework, they have similar kind of behind the scene. They'll be using TensorFlow, Keras, and all those frameworks, but they have made it some more easier. So there is no coding required. You can just update your data set and map the labels and run different algorithms, make models, reuse models, all those things we can build without using code. So Azure ML, that is from Microsoft. Amazon Cloud, that is from Amazon. And Google is also having a cloud provider. That is also getting used, but just not listed here. The Apache Spark distributed computation system has a machine learning library in place. So directly with data analytics, we can do the machine learning part too. That is the advantage. So these are the tools we use frequently. So these are some of the major things which we perform in our projects. So spam filters, recommender systems, ad placement, credit scoring, fraud detection, stock trading, computer vision, object detection, drug design, document classification and attribute. So this is a main automation project which is happening across TCS. So most of the banking and insurance customers, they will have a lot of document to read and process. So before it was a manual process. One person will monitor the PDF files which are 200 pages long, and the required attributes will be extracted from those PDF. Okay. So now using object detection, so we will the machine will read the data. So there are some pattern matching which we can implement for specific attributes. Okay, maybe for shipper consignee details, that kind of area. So without going manual interaction, we can extract those attributes and make it available for further process. So this is the main means number wise. So there are many projects happening in this category. That's why I kept it at the top. Recommendation engines, you will be familiar. So when you go to Amazon, Flipkart, or any other online portal, so now it is widely used because of this social distancing and all. So you will be like amazed. So when you search for something, maybe in Google when you search, you can see the results in Amazon. So that kind of impact means they are connected. Okay, means both these search Amazon details and whatever Amazon Alexa analytics, I think. So right now Alexa is on here. So maybe tomorrow I'll get some recommendation for machine learning books or something. Okay, so that we can have. That kind of things are happening. Even if you are not knowing, that kind of analytics are happening behind the scenes. Okay. Then chatbots. So you will be seeing every online portals, so banking system, mainly bank, in every SBI, ICICI, almost every ICFC, everywhere when we go, you can see when you enter that application portal, there will be a chatbot. So any questions related to any clarifications or something which you need, you can type it there. So they are actually minimizing the support personals. Okay, the server call center service providers, actually they were doing that job before. So at least maybe 50% of the task they can reduce. So mostly these chatbots will be taking care of those things. Self-driving cars. Self-driving cars, see, actually, there are multiple customers for us. As all major players, they are having self-driving car initiatives. So by 2021, mostly there was one customer which I was working. They were planning to introduce their level 4 autonomous car. So these are not fantasy thoughts. Maybe in India, this infrastructure will take some more time, but there are some places in California, USA, California, there are they have approved running these autonomous vehicles. So we have approval to drive autonomous vehicles in California. And some areas like that, very structured roads are there. Maybe in future, some of the areas in India also we can expect, because it is like once it is implemented at a place, the similar thing implementing some other place is like comparatively very easy. So that kind of for the slides we will go in detail about self-driving cars, some things which we are doing and what was the data which we were processing for these specific projects. Then apart from that, data mining in the sense data collections. Okay, so now we have a huge collection of data. From that data, we need to make up some patterns or something like analyze. After visualizing that data, somehow we can make some patterns. Something maybe there will not be a business drive. Business function defined, we need to make it. So that kind of projects are there. And spam detection. Spam detection, if you are using Microsoft mail system, you might have seen it already. Focused inbox will be there, and category, promotional category. Even in Google Mail, you can see social network related. So relatively there are, and if you are traveling somewhere, they will alert based on. So a lot of AI spam, no, it's not spam detection, but classification, object identification and classification kind of things are happening in the mailing platforms. So that kind of things for every individual players we may have to implement. That kind of things are also happening. So again, I was talking about the same thing. So then apart from that, robotic process automation, that comes, I think, this is a different division. I was not part of that, but TCS is having a lot of projects in robotic process automations. So some of the examples are like ATM testing robots. It's kind of an arm. So it will be like using, it will be used to test the scenarios, okay, fraud detection kind of things. So maybe 20,000 use case scenarios, with different patterns which can be tried by a fraud person. That kind of testing. So robotic answer manually will be taking much time to test those things. So that kind of robotic process automation projects are happening. Telematics application. One sample was like I told you about GPS data and deriving driver characteristics. Basically, the idea was to find out is that driver is a risky driver or a safe driver. So based on that, insurance premium calculation. That was the purpose of that application. Okay, so when we talk about autonomous driving, there are different categories. Okay, so level 1 driver assist autonomous car means we are driving right now. We have reverse parking assistance, maybe cruise control, all those things we can consider in this category. Partial automation means autonomous braking, that kind of things. Okay, so partially these things are implemented in many trucks, vehicles. Even in India, a lot of vehicles are having autonomous braking system. So that can avoid up to some. It's a good thing. Like maybe most of the accidents are happening based on users. Like if we are not taking care while driving, maybe mobile phone usage. So that kind of situation, this kind of autonomous braking system, etc., can have. Okay, so level 3 autonomous means the car will be having a steering, but sometime we can take rest and at least maybe you can sleep. That kind of driving, level 3 autonomous, but still it will be having a having all the controls for a driver to control it himself. So level 4 automation means there will not be a steering wheel, so the structure of the car also can change. Okay, so if it is not having a engine, gearbox, steering, and all, even the seating arrangement, everything can be changed. Even the visibility is not a problem. User can sit inside. Maybe glass doors can be like not transparent. Lot of change. Maybe that car will not be even the shape which we are expecting right now. So that kind of things we can expect in level 4 autonomous car. We are working in a level 4 autonomous car project. Okay, so that one, the software part, it was ready and it was under testing. So what we were doing, the test vehicles, they run. So it's like with driver, they will run test vehicles and collect the video data. Maybe next slide I can show you. Okay, so these are the data getting collected from an autonomous car. This is to prepare that car for autonomous driving. Okay, so there are 12 module camera. So there is like one wide angle will be there, then short distance camera will be there, behind side. There will be 12 camera. So that can change based on configuration, but in our implementation it was 12 camera system. So that comes under optics. Then radars are there for detection. So maybe the obstacle detection radar will be used. And lidar. Lidar is like light intensity detection. So like how far, see in the optic, in camera we cannot find the distance of a person or obstacle which is in front of the car. Okay. So lidar is like light, based on light intensity, it can measure the distance. Okay, at least up to some level, lidar can be helpful for identifying the distance. Then GPS data, location coordinates, and all. Apart from that, there are many other things. So steering location, steering angle, all those controls, everything. So those all details will be collected, and approximately it was 2 TB of data for a 1 or 2 hour test time. So that we will, and for LiDAR it will be a point cloud, it's a 3D object detection. That data will be in 3D format. It will be really huge. So in level 4 autonomous, these are the data main data structure we are analyzing. Okay, so after that, IoT and connected car concept came. So this is also not a fantasy thought. Some of the place it is ready to implement. So only because of the legal blockage we are no, it's not in production yet. Okay. So connected cars, I have an interesting video. Maybe when I show it to you, you will get what are the things other than driving the car is going to do.
Imagine a future where
Are you able to
vehicles
see?
talk to one another and to critical infrastructure. This connected vehicle
Yes, sir.
technology. Imagine a future where vehicles talk to one another and to critical infrastructure. This connected vehicle technology can change our transportation system as we know it by enabling safe, interoperable, networked wireless communications among vehicles, infrastructure, and personal communications devices. Connected vehicles provide drivers with 360-degree awareness of similarly equipped vehicles within a range of approximately 300 meters. This secure system keeps personal information private and does not track your vehicle. Drivers will receive warnings that inform them of potential hazards through a visual display, seat vibration, or tone. These are only warnings. The driver remains in control of the vehicle at all times. However, the technology can also support limited automated functions in which the driver only sees partial control of the vehicle. Warnings can help drivers respond quickly to avoid potential crashes. For example, the Intersection Movement Assist application warns drivers when it is unsafe to enter an intersection. The Do Not Pass application warns drivers when it is not safe to pass a slower moving vehicle. The Emergency Electronic Brake Light application notifies the driver when an out-of-sight vehicle several cars ahead is braking. And imagine the value of this blind spot warning application, which lets this commercial driver virtually see what's happening in his or her blind spot. Connected vehicles can communicate with smart roadside infrastructure like rail-grade crossings to alert drivers when a train is coming, even if the driver cannot see or hear the approaching train. Connected vehicles can help with weather-related traffic and safety issues too. This is especially true with conditions such as black ice, where the weather may not appear to be dangerous, but the roads are slippery. Information collected from multiple connected vehicles can help determine when a potential hazard exists, such as icy roads, and warn drivers before they experience them. Road weather data from the vehicles can be sent to traffic management centers, or TMCs, providing detailed, real-time information to help monitor and manage transportation system performance. The centers can then take actions like adjusting traffic signals and speed limits, notifying maintenance crews, dispatching maintenance vehicles to the road, and broadcasting warnings for motorists. Motorists can get real-time road weather information from in-car displays by dialing 511 or by listening to highway radio stations. Motorists will be able to get road weather information on their personal devices before leaving home. Connected vehicles can even help us to reduce our carbon footprint and facilitate green transportation choices. Eco lanes are similar to today's HOV lanes, but with a big difference. Motorists in these lanes agree to drive eco-friendly vehicles and drive at a speed that conserves fuel. Drivers will be alerted about the proper speed with dynamic message signs. Connected vehicle applications can help vehicles to reduce idling and unnecessary stops by communicating with smart traffic signals. Traffic signals broadcast data about their current signal phase and timing, and systems inside the vehicles use the data to determine speed advice for drivers. Drivers could then adjust their vehicle's speed to pass the next traffic signal on green or slow down to a stop in the most eco-friendly manner, thereby saving fuel, reducing emissions, and saving drivers money. Connected vehicles can enhance awareness of unexpected roadside incidents like disabled vehicles, car crashes, police activity, and first responders caring for crash victims. Incident zone warnings will alert drivers about incidents ahead and warn them to slow down and change lanes. Communications could also be sent to first responders at the scene via shoulder radios to warn them of the danger of approaching vehicles. Connected vehicle technology can help control traffic flow and reduce the resulting congestion at accident sites before it gets out of hand. With millions of connected vehicles, our ability to share robust data with each other and with smart infrastructure will continue to improve traffic flow, enhance coordination with transit, and make our communities even more safe and livable. The connection protection application gives public transportation providers and travelers the ability to communicate two ways. The connected network gives passengers real-time transit information so they can more accurately predict whether they will make their next connection. If multiple people on a delayed bus will miss their next connection, transportation providers can adjust bus departures to enable the passengers to make their next connection. Dynamic ride-sharing applications make the logistics of ride-sharing, scheduling, reliability, and communication easier by connecting vehicles and handheld devices. Applications do the matching for us, authenticating users and connecting riders with drivers. The Cooperative Adaptive Cruise Control app helps drivers avoid stops and starts, which can also help conserve fuel and improve traffic flow. And the Q Warning app monitors traffic data to detect stretches of slow-moving traffic and warn motorists to reduce speeds to avoid potential rear-end collisions. Connected vehicle technology can help pedestrians too. For example, the Mobile Accessible Pedestrian Signal System app sends an automated pedestrian call from the smartphone of a pedestrian with disabilities to the traffic controller, holding the walk signal until the pedestrian has cleared the crosswalk. This application also alerts drivers of the presence of a pedestrian with disabilities at the crosswalk. The potential benefits of a connected transportation system, one that is able to enhance safety and mobility and address environmental impacts, are wide-ranging. They will be felt by every one of us, enhancing the livability of our communities and ultimately making our transportation safer and smarter. Imagine the possibilities.
Okay, it's interesting, right? See, actually, even if it is not autonomous car, we can make it a connected car. So all these concepts which we discussed in that, they are discussing in that concept video. So even if suppose it's not an autonomous car, so other features, so most of them up to some level it's already available. So if you are using Google Maps, it's from another device, but most of the functionality is available for us. See, suppose that adaptive cruise control. So when we drive in the signals ahead of you, in what speed you need to travel, and how to avoid the waiting in signals. If the car is giving you some ideas, that would be better, because we cannot manually calculate while driving all these things. But for a machine, it is easily possible. So if that kind of concept can be implemented even without autonomous driving. Okay. So these are the predictions by when this will be a practical thing. But even if it is not completely autonomous, most of these concepts are useful. You can see this whatever useful in near future. Okay, so this is a recommendation engine process I have given like this. Okay, so we already discussed, just sort of giving some insights. So recommendation is mainly based on a business objective, that is like increasing their sales. Okay, so whatever, it's kind of a front office boy, we can say, who is recommending some products or make us more convinced for purchasing one specific product. Okay, so data acquisition time, we'll be considering a lot of factors. Few of them we have listed here: user ratings, comments, cart history, how much money we spent. Maybe the money we spend, they can calculate the mostly, even if we are not disclosing our salary, some of the things we can calculate, and how much time we are browsing that specific site. Those kind of things will be used for data analytics. Okay, and missing values. So based on these 2-3 attributes, maybe combination of other attributes or some other equations, we can come up with new attributes or feature sets. So that kind of data processing will be there in a recommendation engine. Then data exploration means using data visualization techniques. So it will be like tabular data, we will not get an insight at a single look. Okay, so using data visualization, we can come up with more insights regarding the data which we are processing. I think it will help to make the models. So this is one another major implementation project which we are doing in TCS. So that's why I thought of giving a detailed slide for this one. Okay, I think now it's time for showing you some examples. So I have two examples prepared for you. One is mapping earthquake data. Okay, so I will show you the tabular data which we have. So it is having the magnitude of earthquake happened. And if you go to this website, okay, so this is showing US geological survey, US geological survey website. So they will provide the data set for the complete list of earthquake happened in past hour, past day, past 7 days, 30 days, 1 month, all earthquakes. Okay. So this is the tabular data which we have. So it will be having a timestamp when it happened, latitude, longitude, where the location, depth and magnitude, gap. So those kind of things we can read from that data set. So in this specific implementation, we are not downloading this data to the local machine. Directly we are getting from that URL. And in the map, in a world map, we will plot the coordinates. Okay, so let's go on to it. I have prepared the Jupyter notebook because otherwise maybe it will be time consuming to show you completely. You can see my screen still, right? Are you able to see the new screens?
Yes, sir.
Okay. Okay, so Anaconda and Jupyter Notebook. So this will be, I forgot to put it inside presentation, but I feel like that will be a very good tool for you to teach students. So this way, so whatever notes you can give in specific, suppose if you need to give some description, this way you can give description. Process description. So that way, the notes for kids, not for students, not kids, not for students, all those things you can give here and make it as a notebook, send it to somewhere else. They can run the code if they have Anaconda. So that's a Python distribution. It will be having all those scientific calculation requirements like machine learning algorithm implementation, everything will be by default installed. So Anaconda installation is a fairly simple thing to do. So you can just give a search Anaconda Python distribution. So you will get a lot of YouTube channels also. Once it is installed, all these things which I'm showing here, you can try it yourself. Even once after installing it, you can open a Jupyter notebook. Maybe that it will not be a big sized file. You can share it with students or anywhere, or online you can maybe in Google Drive. If it share, it will be like available from cloud. So this is the data set. First we will import the modules. Okay, so these modules are like matplotlib. So this is the library for charting in Python. Okay, so the base map is for geomapping, geography, so world map, or maybe for a specific country or one state in a specific region. All those things you can do using base map. Maybe India a map you can plot in the graph, and maybe the population for each district, kind of things you can plot. So request is for getting the data from internet directly, then CSV importer that are like for getting the data directly from this URL. Okay, so we'll run this control enter if it works. See that time. So here we are getting from this URL, we are getting all the, so for last month, all the earthquake happened. So that data we will get. Maybe I can show you the data set which we are getting from that data URL. See. Okay, so this is the data set which we are getting. So it has the time, latitude, longitude, depth, magnitude of the earthquake, a lot of other details. I think we are interested only in this magnitude of the data right now. Maybe the first one, it's only having. Okay, so directly we are reading from internet the data. And few things. So I found some null values causing issue. This it's not complicated at this much. After this, I will show you using pandas library. There's only this much of code. Okay, that is for only fs magnitude greater than 4.5. Okay, this is for all. Now I will run it. Okay, so we have loaded that data in memory and few data processing we have done as we discussed earlier for processing, making it right for our calculations, few things. So I'm not explaining it here. So if it is null, I'm replacing it with 0. Otherwise, some numeric problems were happening. The framework is expecting numerical value. Okay. So if I run this map, plot base map. It's actually a base map using matplotlib. Okay, so you can see that the real world map and the earthquakes happened in last month. So actually the size is based on the magnitude. So the big one will be having, and also alpha is also maybe multiple earthquake might have happened here. That's why you can see the deep red areas here. And you can see this Japanese area and North America area. So they are prone to earthquakes. Safely, India is like we are at a safe place. There is no earthquakes happening frequently in India. Okay, so this is much simpler implementation. This only we need for plotting this graph. So I just found this code today morning, so it's much easier. And here we are going to show only earthquakes magnitude more than 4.5 last month. So here we are importing pandas library. That is one library for Python to read columnar data, CSV, Excel sheet or something which we need to bring it in Python engine, then this is the library to be used. And matplotlib is for graph plotting, and the base map for geomapping. Let's run this code. So this is a different data set which we are getting. So in the code also we can do the same thing. Okay, so we can get all the earthquakes, and in the code we can filter maybe more than 5 magnitude data we can filter. Maybe one single location we can filter. Maybe only in Japan area, what was the which all earthquake happened, that kind of thing. Everything we can visualize this way. So this is a small sample of data visualization. It's pretty easy. So you can see that just 15 lines of code. These are like 2 blank lines. You discover that just 15 lines of code, you can make beautiful charts. So data can be anything. You can maybe your student locations you can plot from GeoMap. How long, how far, the farthest distance. If you visualize these things, it will be easy to understand. Otherwise, if we see the tabular data, nothing will be sensible. This is just to show you the data visualization possibilities which is present in Python. Okay. The next one. Okay, so this is a machine learning sample. So ad placement based on user interest. So I was talking about Amazon and Flipkart mainly. So here we are going to implement a miniature of that similar system. Okay, so the basic idea is to identify a specific user is going to click on an ad in the sense maybe a product link or something which is going to be, so that interest, that user interest we are trying to predict based on the statistics. Okay, statistics for the similar other users. So I will show you the data set. This is the downloaded one. So I have downloaded this data set to local machine. So this is the process which we are going to do. First, we will import that data into Python and exploratory data analysis we will map it in some charts and that visualization will help us to understand the kind of data, the interest, everything. So data visualization we will do. Then sample model generate. We will make a model, a simple model to predict would in future a specific user will click on that ad or not. Okay, so that evaluation also will be there. Let's see. Okay, so this is another Jupyter notebook. So I have already given the code, everything here. Okay. See, these are the data. In this data set, we have these details. Okay. 1 second. Let me show it. So this is advertising data. So here you can see daily time this specific user using internet. So this is like in hour, no, in minutes, 68 minutes he is using. Age of that user, then area in income of that user in dollars. Daily internet use. Okay, this is daily internet user. This is like specific in that specific website how much time he is spending. Here actually in real implementation there will be a category for each and every advertisement. So these we are not considering now. We are just going to find out if would that user will click on that ad or not. 0 means he's not clicking. 1 means he clicked. Okay, country is also there, but for us male or female that we will consider. So that can bring up some interest. Okay. So that kind of features only we are going to take. Timestamp anyway we are not going to consider. So let's go to the implementation and see how it is now. Okay, so as usual we are importing pandas for reading the data from this file. So NumPy if you are planning. Few of the things we can by default maybe histogram and kernel density chart, that kind of things we can make using Seaborn library. Okay, so that's why we imported that. So here we are importing all the required modules. So here we are reading data into memory. Okay, so that is like downloader. I have it here advertising data. So when I run this line, it is in memory now. So there are thousands of observations. So you can see that in this samples we have 1,000 samples. So one excluding the heading, we have 1,000 samples as input. Okay, this line is actually not required, just to identify. Okay, so that is not required. So if you run head, so this is a data frame set function. So you can see the same thing. We went and saw in the Excel sheet, but the same thing you can see it here. So these are the similar thing which we saw in Excel sheet. Okay, so info will give how many the data type of the column, and then how many samples are there, which are the fields. So there is a function called describe. So there we can get little more insights. Okay, so in the data, so this column, if you consider the maximum age in this users list are 61. Okay, minimum is 19. So the 19 from 19 to 61 age range only there in our data set. So the maximum internet usage time that is spent outside, you can see here daily internet usage, male, female consumption, click. So it's like basic statistical information regarding the data set. Okay. So this is the histogram, okay, which shows the age categories. Okay, so you can see that 30, 40, that range is the maximum, where the maximum users are present. Then income is same, age is income. Okay. Okay, see here, this y-axis we can find area income of the person, and here it is age. I can see that from 1920, that earning starts until 40, that is the maximum amount of income for almost everyone. As the reality, when we grow older, the salary is going to decrease. The similar thing. So this visualization will give you a proper understanding of the data. So that is the main purpose of. So all these charts are getting generated using that Seaborn module which we imported. Okay. Then age and daily spend time on site. Okay, that will be another chart. So here also you can see that 20 to 30 to 40, they are the I think the heat map is right better. Okay, so the maximum usage is at age and time spent on internet. That is also logically correct. So when we grow older, we'll be finding less time to do all those things. So daily time spent on site plus internet with internet usage, okay, versus internet usage. So there is a clear separation. We can see maybe when you get familiar with all these charts, you will get more idea about what it represents. So there is a pair plot option in C1. Okay. It will take some time because there's like many charts. Okay. So here you can see all those input parameters, input attributes. By default, this library will generate chart for each and every attributes, means two combined attributes. So daily time spent on time plus daily spent on site age. So here we can see this red mark shows clicked, the ad clicked category, and blue shows the users who didn't click that. So everywhere you can see a clear separation between both. Okay, so age, all these parameters are influencing this result. That's what we can understand from this data. So this I'm just showing you because using all these charts, you can get fairly good insight about your data it's going to be used. So now logistic regression part. We are importing the modules required for logistic regression from Skype. Okay. And here from data, we are splitting X and Y, so labeling our data. So these are the input attributes we are mapping, and the result Y we are assigning clicked on ad. Okay. So X and Y is the result, X is the input. So we are splitting, we are labeling the data. So here is the part which we told, right, features and splitting. Okay, here we are splitting the data into test and train set. Okay, training, we are giving 33%. So from 1,000 samples, 33% means 330 330 records will be selected as training set, test set. So that will be like using that, this model evaluation we will be doing. Then random state means it will be taking random entries. So it will not be in an order. So otherwise, it will be taking based on the maybe 1 to 770 will be in the train set. So random is better because that will make more accurate results. Okay, so we are splitting it to train and test sets. Okay, sorry, this was like test and test with module import here. Logistic regression is getting imported here. So we are importing the module for scikit-learn. And the model algorithm we are specifying here. And the train and test data, X-train and Y-train, we are fitting to the model. Okay. So in memory, we have created the model. In real case, we will be saving this model to somewhere, some binary format. We will save it. But for this purpose, I am not doing that. We can do the in-memory process itself. So we are going to get some predictions. So in this thing, whatever in X-test in the sense, we are splitting some of the records in test documents, right? So 330 document records will be selected in test document. So we are going to predict result for all those things. So the results are there. So if you bring this predictions, see for 330 entries 0, the first entry is not clicked, second entry is clicked. So 1 means clicked, that user clicked on it. 0 means didn't read. This is based on prediction using the model. Let's see in real case how it is coming. So report, for this test details, we can build a report using this framework itself. Maybe optionally confusion matrix also again. You know the confusion matrix, right? Confusion matrix means using that model, how many false positive, false negative, and 2 positive and 2 negative, that report actually. So we can print both. If you print classification report, we can see that the accuracy is 91%. It's fairly good, but maybe that is based on our purpose. So 91, so in some cases 91% accuracy will not be a good thing. But we have limited sample, and in this case, as a test data set, we can say it's a good one. And recall, this thing shows how many false positives were there. So better confusion matrix, we can see that easily. Okay, I did not run this line. Okay, so this is the confusion matrix: true positives, true negatives, and false positives, and false negatives. Okay, so this one, this entry and this entry in total shows the percentage of true. So in 330 documents, how many are predicted correctly? So it's like 156 plus 143. 156 plus 299 were correct, and 31 was a false prediction in this model. So we can say that was few predictions are wrong. So X-test values we can see. So it is showing 531, 521. So these are the entries for 521. 63, 8 was 29. See, these are the input details for that test data. And Y-test, if you print, see it was like predicting 1. 1 means that user clicked on it. Okay. So let's compare in real data set. Okay, prediction for row number 61, 560, 506. Okay, let's see 506. These are the entries. You can see that same we have passed here. These are the entries, sample entries. And in the Y test, 506 is having 0. That means in the real data set, user didn't click. And here also we got the result 0. That means based on that model, predicted value is correct. So I found this entry is wrong. So here actually it is clicked, but in this calculation, based on this model, it's coming wrongly. That is there because we have only 91% accuracy for this model. So somewhere it can go wrong. Suppose I'm running this. It is predicting 0. Okay, so this 521 entry is predicting 0. Actually, based on the real data set, is clicked. So that is because we have limited set of data set features here. But when we consider the real feature set, suppose more possible driving factors, if we are considering, it will be like real accurate value. Okay, so this is just for the demo purpose. I have prepared the very minimalistic data set and the result. Okay, so based on that model, maybe we can inject different parameters here. See, suppose now we are going to test a person which is having 50-year-old and he is using internet for just 15 minutes. 30 minutes in total, internet usage, and salary range is 2000. Let's see how it happens. Okay, predictions. He will not click it. So logically, it's correct because when we in the parameter, he is like having less salary and he is not using internet that much. It could be correct. So this is the basic model creation and prediction. So using this code means this model in the real world applications, we can build real-time predictions. Say suppose when we browse the website, this model will run based on the user details. It will predict, okay, this kind of this user is not going to click. So let's give him the right thing. So that time itself we can present what he is interested. Okay, so that kind of things you are seeing daily in Amazon, Flipkart, or whatever online portals. So this is the miniature of those samples. This is like very minimal list of attributes which we are using, but in real case there will be thousands of attributes they are considering. You don't even know what are the search results you are doing, and a lot of other things in the car, how many you spent, or maybe you bought one specific equipment. Maybe for maintaining that equipment we need to purchase some other things. So suppose you bought a car, new suppose maybe one TV we bought from Amazon. So they can easily guess that maybe the sound bar or some other accessory for that TV can be purchased. So that kind of things, a lot of other features can be included and make this model more practical and realistic. So this is what happening behind the scenes for most of the recommendation engines. I think, okay. Simple samples, I think it was informative. So here I have given few links. One is like some open source car driving, autonomous car projects. Okay, so you have the access to complete code base for lidar, radar, all those handling code. So you can easily go there and see what is happening. And even if you are not having the car to test, there are some simulators. Using that, you can try out few of the things. So these are all open source projects. Then Kaggle.com. Okay, one another interesting website I'll show you. Okay, these are like machine learning projects, open source, and Kaggle.com. So this is another good site for machine learning interested people. So there are a lot of data sets available. Okay, Indian food, TripAdvisor, trending YouTube video statistics, COVID-19's impact on airport traffic, a lot of things. So if you go and check this data set, a lot of interesting things you can find. Competition rankings, experience on Spotify. So if you go to this data category, you can see a lot of bunch of even notebooks, Jupyter notebooks you can find. FIFA data visualization, maybe players, sports interested people can find. Lot of things. You can go and find thousands of samples here. It will be like even code samples will be there, and even data visualization will be there directly. COVID impact on airport traffic. This is an interesting data set. So it's like air traffic reduced very much, and nearly there is no air traffic. So what was the difference we can analyze here? So this is like real world data set. It's not a mocked one. This is like based on the real statistics. So you can find a lot of things here. So this is a very useful data website for machine learning students and who are interested. Okay, I think that's from my side. Hope it was informative. If you have any questions, please ask.
Thank you, sir. There are a few questions. We'll share that. We'll share the screen.
Yeah, sure. Differentiate between deep learning and machine learning. Okay, so deep learning is kind of neural network. You know that, right? So it's kind of the algorithm is functioning like a human brain. So neurons architecture is a very vast topic. So basically, it's like normal machine learning. It's a linear algorithm based on some coefficient. We'll see, suppose based on the features, we will come up with a coefficient relation. Okay, it will be based on some statistical calculation. But deep learning side, will be that propagated values and weightage, error calculation, a lot of things. It's like multi-iteration happening behind the scene. It's like quite complex compared to normal linear regression kind of algorithms. The next one, how will you know which machine learning algorithm to choose for your class? Okay, I think this one I already explained to you in a slide. You saw that this one, right? So this slide, choosing right algorithm. So here, this is actually a flowchart. Okay, so first consider your data set. What is the data set you have? What kind of data you have? So predicting a category, is that your intention? Is the data is labeled? Number of categories? No. Or unknown category text data? Is it text data? Feature should be important. So all these things you can consider. Yes, you need to answer yes or no. Go through this loop. Somewhere you will reach in this category. So that's the right. Even for a experienced person, it will be sometimes difficult to identify the right algorithm. So these kind of flowcharts will be very helpful. And you can see, you can just search for scikit-learn algorithm cheat sheet. So apart from this one, you can find a lot of other things. So that will be helpful. So that is like a lot of people have already tested that kind of algorithm. They have come up with good results. And even in Kaggle you can find these projects and how which are the algorithms getting used. That things you can. Oh, I was not, you are not seeing my screen, right? Hello?
Yes, sir.
Yeah, actually the second question answer, I was answering. I thought you
Yeah,
were
yeah.
seeing my
No,
screen.
sir.
So actually
Ours.
there is a, yeah, there is a flow chart I given in that slide. It's slide number, share it again.
Yes, sir. Uh, um,
1 second, which will, when will you use classification or how much?
sir, are you able to share?
Just a minute, just a minute.
Okay, sir.
Listen, listen. You see my screen, right?
Yes, sir.
Okay, so this flow chart. So this flow chart actually, the live one you can see here. Okay. So I have given the link also there in that presentation. So if you go here, this is a flow chart. So there are some questions. So this is pretty straightforward questions. Okay. So if you are going to predict a category, is your data is label, number of categories known, samples greater than. So all these simple questions. So simply go through this, you will reach somewhere in this tree. Okay. So that is one thing. So maybe based on the experience also you can see maybe so the logistic regression was we were using in the salmon, right? So that kind of similar scenarios we can use. So that is also purely based on experience plus the facts. So these kind of cheat sheets you can use to. There are many. So one of the best is this one. And here you can when you click on in this website when you click on that specific uh, algorithm, you can see that the data visualization, the theory, the samples, everything you can see there. I think that describes. And the third question, can you please read?
Yes, sir. We'll share the screen, sir.
Okay.
Is it visible?
Yeah. Yeah. When will you use classification or regression? Okay. That is also there is another one. Just a minute. Let me resume the presentation again. Okay. So this one here. Okay. So are you going to use supervised learning or unsupervised learning, semi-structured? So this is the first category you need to identify. That is like pretty straightforward. And here you can find some sample implementation. Okay, sales forecasting. So similar categories you can bring under linear regression, support vector matrix, image classification. You can bring it under support. So these kind of so you will get a lot of cheat sheet like this. So that will be helpful. So there is no straight answers for selection that is based on the accuracy we get. So sometimes we need to test those specific algorithm on our data set and find out the accuracy. Maybe the confusion metrics we need to find. So basically, the straightforward things, few of the categories are already there. Maybe this will be helpful. Similar things we can try like that. Otherwise, maybe the fine tuning of the algorithm you need to find out based on the result you are getting. And also maybe multiple algorithms you can use. That is also another technique, and the result will be combined with all of them. Okay. And the third question, it's better you can read. I think you don't need to share it again. Switching. When will you choose fourth one? How much are accepted type of? In self-driving car, error is not acceptable. So that will be quite accurate. So that is like we need to drive that car in all possible condition, and if something unidentified or something, in that case, machine should halt. Something like that we need to plan. So error should be very minimal. There is no, because that is like a we are playing with life of passengers, right? Is it possible to keep the same bin condition bandwidth of network? I think bandwidth is not a concern in India. So I have experience in other countries too. I think one of the best connectivity we have here in India, even considering all this population, this geo kind of movement nowhere in other countries. Second. So maybe the broadband speed is much higher. Right now, bandwidth is not going to be a barrier in India. Okay, so it is satisfactory. The main thing will be the population and the traffic, the amount of traffic, that will be a problem. So here, when we consider that, when we consider the implementation is kind of considering possible areas. Maybe not everywhere in India it is not possible, but there are places we can try it, and maybe dedicated for autonomous driving. Some initiative like that can come. And once the infrastructure improves, so there are comparatively many challenges in India. That is mainly the population. So the infrastructure-wise, bandwidth-wise, I don't think. Yeah, roads is a limitation. Roads are limitation, but bandwidth and other things, I don't think it's a problem. And also connected cars, a lot of concepts which we are seeing now, even without autonomous driving, we can implement. Okay, so maybe whatever possible that can bring in our life. Otherwise, we have done. We are not able to. We will be not able to do that.
If there is anyone, any more queries?
Am I audible? Hello.
Yes,
Yeah,
yes.
yeah.
Yeah. Good evening, sir. First of all, thanks a lot for giving us time and shall share the valuable ideas regarding AI and data learning. So, sir, I have a question to you regarding cloud computing, because in my last trimester we had a e business, and we had a chapter in that called cloud computing. So, sir, my question to you is: we have learned that companies they have to bear huge amount of cost if they will be if they are they need to have their own database management systems and their own physical structures, and apart from that. Over the period of time, there is a change of customer demand as well. So most of the time, company prefers to get with the clients to the companies like Amazon or Google if cloud
Yeah.
computing is concerned. But sir, I mean, I was also going through a survey in 2018-19. Almost more than 90% of the customers, they are much more concerned about the data security.
Mhm.
Okay, so sir, according to you, I mean, companies they are in a dilemma whether they should, even data sensitivity is also there. Okay, so
Mhm.
so sir, according to you, what are the main factors should company put in their mind before going to the companies like as I mean Amazon or Google?
Okay, so actually now clients are more convinced to use that kind of what we say the cloud computing infrastructure. Okay, so even Army, US Army, so cloud providers are giving some specific infrastructure for this kind of sensitive data. Okay, so that is like it's isolated from their normal networks. That kind of infrastructure is there. Okay, so military related things, government applications, That kind of things, specific infrastructures are provided. So before I know that 10 years back, not 10 years back, maybe 5 years back, one of the customer with I was working, they were reluctant to move their mail to Google, Gmail. They were considering Google. They were using Lotus Notes infrastructure. So now recently I knew that they are ready to migrate it. So when we considering data security, I don't think it will be a concern. There is a challenge like our data is located in a remote place, so they can do the analysis. But maybe using the legal restrictions, they are providing more options for that. Even say when we consider Germany, they have some policy like some parts in the Europe, there only their infrastructure should be provisioned. So that kind of things now the customers are more convinced. Even banking customers usually take care of their security much high, but they are also, see, I work for a banking customer now, so they are also moving their infrastructure to Azure. The good thing is anytime we can grow or shrink. Okay, so now mainly because of this pandemic situation, all who might have moved to cloud infrastructure will be benefiting. I mean, so a lot benefit will be there for them because their infrastructure is not disturbed. Say suppose the companies which were using on work instead of VDA on working, so they have to ship their machines to local means employees workplace. All those things were happening, but companies which were using VDAs and all, literally they are not affected at all. So that kind of benefits now people will be realizing more, and cloud computing is going to dominate. That is one true thing. So cloud migration is the basic thing. TCS right now discussed. So even the units are like divided in the cloud technology based. So that much changes are happening. A lot of customers are moving to cloud based, and even the startups. Okay, suppose you are implementing a application. So suppose and you don't have any users right now. So suppose you are implementing a food related application. You are expecting only 100 or 200 initial users, and later on maybe 2 3 months later you are expecting maybe 500. So that time you should be able to scale it. So in a on-premise infrastructure, it is very challenging. But cloud is like, see, maybe you are not completely sure what will happen. So based on that, you can build the infrastructure. So that flexibility is there. So when we realize the advantages, the security concern is also like there is a agreement, legal agreement. So we can, if there is something broken, they can see your means they can ask them penalty, something like that. So that's more convincing. That is happening right now. Even banking customers are moving to cloud-based infra.
Okay, sir, thank you. And sir, one more thing, I just want to know your views. I also read that switching cost is very huge, or customers will be in a vulnerable situation if customer is gonna choose Amazon, and if this is not possible, but in future, if Amazon will be the out of the market, if cloud computing is concerned, then the customers will be in problem because they cannot shift their entire data from cloud to the another peers of Amazon. I mean, Amazon to another.
That's not
So,
completely true. See, now all these cloud providers are giving us options for backing up data, storage, so backing up data and also infrastructure migration. Okay, suppose Microsoft Azure is giving you option for, see, you might have already purchased Windows license, maybe server license you will have. All those things you can migrate without cost. Without cost in the sense that license, whatever you purchase Windows or some that kind of software licenses, you can use it cloud premise also. And anyway, there will be a shift in investment, like whatever you have purchased Apart from that, some additional cost will happen. It will be incurred at the initial time, but later on it will be a flexibility. Main thing is like based on your usage requirement, you can configure your infra. So that is not possible otherwise. Shifting, lot of options they are providing, the lift and shift mechanism, that kind of thing. When you migrate, say suppose you have a machine, you have the data inside, maybe you can send the data hard disk by postal and they will import that data for you. That kind of facilities also they are providing. Apart from that, maybe you can install some agents in your machine, so that will take care of the migration, even your software environment plus data. So that is not that hard as we think. I think the things you told, it's not completely correct.
Okay, thank you, sir.
Thank you very much, sir, for a very informative session. So with this, we are winding up today's STTP. The next session is scheduled at 10 a.m. tomorrow. There is an announcement regarding tomorrow's hands-on session on introduction to robotics and components for building a robot. Kindly, participants, please note, kindly install Arduino IDE in your system for tomorrow's hands-on and demo session. You can also utilize the hardware if it's available. You can also utilize those. So thank you, sir. Thank you for joining us today. Thank you very much for the informative session. Thank you.
Yeah, it was a pleasure. Thank you. Have a good day.